Hello everyone, so let us continue with Mininet. So this is the part 2 of the web page on walkthrough of Mininet. Okay, so here we can start with run a regression test. So you don't need to drop into the CLI. That means you don't need to go into the Mininet console. Mininet can also be used to run self-contained regression tests. So you can directly run a command, and then Mininet is going to construct a particular network with the topology, and then it is going to show the results. Okay, so everything will happen at a go. Alright, so let us try to see if that is helpful. So here we have this particular command. So let us take this command. Here we have explicitly mentioned test, and we say that we ask Mininet to do ping pair. Let us see how it works. So let us give the password. Great. What do we have here? Mininet created the network, then added a controller, then added various hosts H1, H2, then added various switches, but in our case we have one switch. Then the links are created. We have H1 with S1 and H2 with S2. Then we configure the host, or rather Mininet configures the host. Then the controller is started and the switch is started. Then we have these pings from H1 to H2, then H2 to H1. Okay, and then we get the results, and then everything associated with the network is going to stop. And then we are also going to exit from the Mininet console CLI. Fine. So what do we see in this particular comment or this command? With this command we are able to create the particular test network, and then Mininet is going to test the various links that are associated with the network, and then after giving the result it is going to gracefully come out of the CLI. Fine. So this is a very useful tool in order to begin your experiments with Mininet. Then we can also go for this IPERF. Okay, so we can go for the performance of the network with the help of this command. So let us also try this, and let's see what we see as an outcome. What do we see here? We see the same type of scenario. Once we gave this particular command, the various controllers and the switches got triggered, okay, or got created. In our case we have one controller and one switch. Then various links got established, then various devices were started, and then once it's done, this IPERF is going to give you the result as well. Okay, so what does it show? It shows the testing TCP bandwidth between H1 and H2, and the result is this. So these two different values show the bandwidth that has been obtained or determined by doing test. And as soon as the result is obtained, the controllers and the switches and the various machines, they all get stopped, and then the control comes out of the CLI. Okay. There is a big difference between ping pair and IPERF. Ping pair just goes for ping in order to see if the links are fine, but IPERF goes one step ahead and also gives you the information about the links. Fine. Then we can move forward. And yes, students, we have not observed the topology of the networks we have created. That cannot be directly done through Mininet. You have to go for controllers, different types of controllers like OpenDaylight, in order to visualize the network. However, there are various resources you can go through where certain examples are shown along with the topology. Okay, what do we see here? We see one of the examples here. We have two machines, and then we have a switch, and then one controller is controlling that particular switch. fine. There are various other tutorials as well where you can explore the explanations on how a particular network will look like based on the commands that you give. However, we simply want to go through the walkthrough, the introduction of Mininet and the walkthrough of Mininet to find out what it consists of. Then we come to changing topology size and type. Here we have we have been provided with some examples where we try to go or divert from the normal topology that is established when we simply write sudo space mn. Okay, so if you want to go for your own topology, then you have to know how to write these commands. We have two examples shown here. Here topology is that we will have a single switch, okay, and then 3 machines are going to connect to that particular switch. However, in this case we have as you can see here with a linear topology where each switch has one host. Okay, so each of the hosts will have one switch and all switches are connected in a linear fashion. Okay, I don't want to run it. You can just run them and just see. Okay, most of the things will look same, which means that if you go for a default one, let me show you, it's better to show it. So this is the very default one, then you exit, that's totally fine. But if you go for a different topology, okay, based on maybe some experiments that you want to do, then you can go for them as well. For example, in this case you can see that 3 links are created. And we have how many switches? We have a single switch, but all these hosts are connected to the switch. So H1 is connected to S1, H2 is connected to S1, and H3 is also connected to S1. Then if we go for the next example, okay, if we go for the next example, what do we see here? How many links do we have? We have 4 switches with 4 hosts. So these are the links that we will have. We have 1, 2, 3, 4, 5, 6, 7 links. Why? Because each of the hosts is going to get connected to the switches. So we have H1, S1, H2, S2, H3, S3, H4, S4. However, the switches are also going to be connected. So we have S2, S1, S3, S2, and S4, S3. Okay, so try to draw these figures and see how the topology is going to look like. These are the links we have, so you can easily draw and find out the visual representation of the networks. Okay, so let us move forward. Then we have a special feature in this Mininet commands. You can also give the bandwidth and the delays that needs to be associated with the links that you are going to create. So here we have an example here. You can directly take this particular example and then you can just simply copy paste it. Okay, that is cool. We have been able to create the various links, and we also have the values that are associated with the links. Okay, from H1 to S1, S1 to H2, then H2 to S1, S1 to H2. So these are the informations we have. As you can see, we have a bandwidth of 10 and we have a delay of 10 as well. So we have, that's why we have 10 megabit and 10 milliseconds as the bandwidth and the delay. And then further you can experiment on it. You can run commands like iperf. So if we put iperf here, then a particular test will be conducted. So testing TCP bandwidth between H1 and H2. And yes, we have also obtained the results. So these results match with the values that we gave, right? So as it was 10, it is nearly 10. We have 9.5 and 11.8. Okay, so in this particular example, okay, we can also go for pinging. So we can also go for pinging between the 2 machines. Let us do that as well. Okay, all right. So here you can see that the RTT, okay, the round trip time is supposed to be around 40 milliseconds, and it is correct because here you can see it is 43, 42, 41. So we can see these values here as well. Okay, because this delay was 10 milliseconds. Right, so you need 4 links to go to a particular machine from one machine, right? Here in this case we have to go from H1 to H2, and in order to go that, we have to go through the switch as well. So we need there will be 4 delays associated with it, because here we have one switch, right? So H1 will go to S1, S1 will go to H2, again from H2 to S1, then S1 to H1, right? So we have 4 links with us, and each of the link has 4 milliseconds of delay. So that's why if we do 10 milliseconds into 4, it is going to be 40 milliseconds. So that's why we have 40. So all these values are related. Fine. So in terms of assignments, you may be asked to create a link and find out the delays and bandwidth observed. Okay, for that you have to go for maybe pinging or even for iperf. Fine. So let us move forward. Verbosity is how much information you want to show for the various operations that happen in Mininet. You can either go for debug or go for output, and before that you have to go for the flag of -v. So please try out this. Please try out debug and output and see what amount of information actually is shown by the Mininet when you run various commands or you do various activities, okay, inside the console. Then we have this wonderful feature of APIs. So apart from running these commands, you can also apply Mininet using programming languages like Python. So in Python you have various packages with the help of which you can construct your topology and do various activities with the help of Python code. And this is a very simple and beautiful example of this. So what you have to do is you simply have to make it a Python file, and then you have to run it using this particular command. Okay. What I have done is I have simply copied it and pasted it. So let's see if it's there. Yeah, it's already there. So in documents I have just created a folder Python_codes, and then I just kept that Python program here. And now in order to run this particular program, what we have to do is we have to run this particular command. What we have done here is we have created a particular topology where we will have 2 machines, H1 and H2, and switches S3, S4. Okay, and we are going to link them with the help of this code. Okay, please go through them. Please go through the various functions that is available under the packages in Python. Fine. So let us try to run this particular code. Let me copy it, and then let me exit from the current Mininet CLI. Okay. Now where are we at this moment? We are in documents. So let us go to Python codes. I hope it is here. So we have Python codes. Okay, and we have this particular program with us now. We have to paste this particular line. However, we have to make certain changes as well. So let us do that. Since it's a custom topology, we have to mention the custom flag, and then we have to refer to the particular directory link or directory address. And since we are in the current folder where we have the file, we can simply write down the name of the file itself. Then we will go for my topo, which is named this is the name of the topology we have here. You can see here it is my topo. So this name is representing this particular topology that we want to construct. And then we are just going to go for a test attempt where we are going to ping from all the machines to all the other machines in that particular network. Fine. So once we run it, we see that things are happening fine. We have these links H1 to S3, then S3 to S4, and S4 to H2. So just take a pen and paper, draw it. Very simple topology with us, right, where we just try to ping. Okay. H1 to H2 was pinged, and from H2 to H1 was pinged, and we found that all the packets were exchanged without any drops. So we have 0% drop, and then finally the links are closed, and then we come out of the console, we come out of the Mininet CLI. Great, that is perfect. Then we can also go for other features like -mac or --mac. So if you give this particular option, is great, because if you see, if we don't give this --mac, then we are doing this where the hardware address that you say is hexadecimal and very complicated as well. It's very hard to remember it. However, if you give this particular flag of --mac or -mac, what happens is you get a very sequential kind of MAC address where you can see it can be read as 1 because all the other values or digits in other places than the first one are 0. So it's very easy for us to keep track of the various traffic information that we get, and we can do analysis very properly. Fine, so that is cool. Then we can go for Xterm display as well. You can skip this for now and directly go to this particular reference here. Let me go to the exact place where I want to be at this moment. And before that, here you can also run various Python. You can basically use the Python interpreter with the help of py and all, so you can anytime explore them. That would be very helpful for you in the future. However, I just want to go through the other things in this slide. In this particular site, we have this command called down. If you want to just disable a particular link, then you can go for down. And again, if you want to make it run, or you want to enable the particular link, then you can again go for up. Fine. And then finally you can also go for individual terminals for the various machines. So in our examples, we have always considered H1 and H2, and we can run separate terminals for H1 and H2 with the help of this command. Okay, and then we have Python API examples here. You can go through that anytime you want, and then introduction to Mininet, where a lot of content is available to understand the Python API. Okay, all right. So then let us try to take this and see what happens. I hope Xterm is available. Let me go back to document folder, just for convenience, nothing else. Okay, then we are going to run Mininet. So we have mn, so sudo mn. So we have triggered the creation of nodes H1, H2, and let us see if we are able to create separate consoles for H1 and H2. Yes, so we have it. This is going to be wonderful for us to make things more systematic and more meaningful. We can assume that these two terminals belong to different machines, and then we can treat this particular terminal as terminal for H1 machine and this for H2 machine. So if I do config, I have config here, and then we see it is ETH0, right? It is H1 ETH0, and I think you will not be able to see this on your screen, but you just try it out. You will see that things happen perfectly. If you type ifconfig here, you will find here the interface name is H1 -ETH0, and if you do if config here as well, then here you will see it is H2 -ETH0. Okay, so that is fine. That is really nice. Now you can treat it as a terminal for H1, so you can do all the things basically that you used to do in your normal terminal. However, there will be certain restriction, of course, but most of the things will be very common as you do in a normal terminal. Okay, you can bring from this machine to other and so on. If you remember, when you use ifconfig in the Mininet console, that is in this console you always have to write it with the host as well. So it was something like h1 ifconfig and so on. However, when you are using these X terminals, you need not write down H1 or H2 before ifconfig command, because the entire terminal is dedicated to that particular node. So you can directly write ifconfig, and then the machine is only going to show the information with respect to H2 or H1 or any other node that the terminal belongs to. So that makes things very sophisticated. Okay. And with this you can do a lot of experiments as well. You can run various commands to see how they are interacting. You can create a server at one end and then try to make the other one as a client and see if the requests are properly responded or not. Okay, and then you can go for pings as well and various other stuffs for interaction. And then you always have your Wireshark ready to help you. Here you can see you have the switch Ethernet, so ETH1 and ETH2. So whatever packets go through this particular interfaces, you are going to see the information. So you just have to click it, and then in this particular interface you will see the information, the traffic information associated with that switch. Fine. So whatever concepts you currently know about networks, try to implement it and see if you get the traffics or not. You can go for maybe ARP, then TCP, UDP, ICMP, and so on, and see if the packets are reflected in Wireshark or not. So with that, I would like to wind up for now. So practice is all about learning more and more. So try your best to explore more and more, and try to polish your concepts on Mininet. And then when you have perfected using the Python APIs and understanding the various commands, then you can go for controllers. Okay, there are so many different types of controllers like POX, Open, which is the default one, and then we have Open Daylight and so many. So you can go for unlimited exploration on Mininet. So with that, I would like to wind up this video. Thank you.